I'm Anil Kumar, and here is a practice question to find equation of plane in scalar product form. The question here is, write the vector equation of the plane in scalar product form. The question is, a plane 7 units away from origin and perpendicular to the vector 3i plus 4j plus 5k. Now, vector equation of a plane in scalar product form is written as r dot n equals to capital D. And when we are talking about distance from origin, it could be written as r dot unit vector n equals to distance from origin, right? So these are equations which you can use to answer the question. What we are given here is that the plane is 7 units away from origin, so we know the distance d is 7, right? And it's perpendicular to the vector this. So that means the normal is given to us as 3i plus 4j plus 5k. Now, since we are given the normal, we can always find the unit vector in this, correct? So the unit vector will be normal divided by its magnitude. Is it okay? Normal divided by the magnitude. So let's find the magnitude of this. So the magnitude of the given normal is square root of 3 square plus 4 square plus 5 square, which is equals to square root of 9 plus 16 plus 25, which is equals to square root of 50, right? So, and you could write this as 5 square root 2 also. Perfect. So 5 square root 2. So that becomes the magnitude, and therefore we can write this unit vector as 1 over 5 square root 2 times the vector, which is 3, 4, 5. Is it okay? Now, that is what we get. Now, since we know the distance, we'll use this equation, which is r dot n equals to the distance d. R is the position vector. R dot n is, this is the unit vector, n dot d. So r dot n, which is this expression which we just got, which is 1 over 5 square root 2 times 3, 4, 5 equals to d, which is 7 units. Is it okay? So we could rearrange this and we could write this as r dot 3, 4, 5 equals to 5 square root 2 times 7, or we can write this as r dot 3, 4, 5 equals to 35 square root 2, right? So that is how we can get the equation of a plane 7 units away from origin and perpendicular to the given vector, right? So that is how we could do it. I hope that helps. Now let me relate these two also. This is the normal vector. In case you want to use this equation directly, you could have used like this also. R dot n equals to capital D, and then you can say r dot n divided by the magnitude of n is capital D over magnitude of n, or r dot unit vector n is equal to d. So that thing, d divided by n factorial, is distance d, right? So you could relate that also in this fashion, correct? So I hope you understand and appreciate how these things are related, right? So that becomes the equation of the plane where r is a position vector of any point on the plane. That's the normal vector, and that should be equal to, this dot product should be scalar 35 square root 2, right? I hope that helps. Thank you and all the best.